Start with application hosting then. So we have the basic architecture where you can see like clearly separation between the control plane and the application hosting environment. So if something happens or you want the switch to operate in just a switch mode, you can use only these pins. If you want the application hosting environment, you can leverage that one for the free resources that are left out from the switch resources. Basically in Catalyst 9000 platform, we have made three major enhancements to give you application hosting environment. Basically we're using a CPU based on x86 architecture, which is most of the containers and virtual machines use. We're using 16 gig of memory, of RAM memory, which gives you a lot of space to store containers and manage containers. We also have added USB flash drive with 120 gig capacity, so you can store your containers. The containers can store their data or virtual machines. So, in the with 94,000 family, actually we have up to 1 terabyte storage on SSD hard drive that you can do in the supervisor. So now you can see the switch host applications, and what we'd like to show you like how does that works on the switch itself. So we have the network device and the virtual machine that runs on UCS. The application that is hosted on the switch itself is going to look like that. So you have the container or the VM running, and that gives you a lot of information with regard of how much resources, memory, CPU, disk space is consumed. But it also gives you information how you can directly access the virtual machine of the container from the external world without need to go to the switch itself, as you do from a regular server point of view. So now, let me show you the agent that runs on the switch itself. We have access to the GUI the same way as we're going to have as we're running a server, and you can see the GUI and the results that it does. So in the current test that we have like one virtual machine that runs on the switch and 3 virtual machines that run on the UCS machines. So with perfSonar we measure the latency, traffic loss, jitter, throughput, bandwidth between these machines, and we use the switch Catalyst 9000 family on the path, and we can see how the application performs using the path through the switches. So let me show that on the dashboard. Okay, so this is the application. You can see that it's measuring the throughput. So this is from application running on the Catalyst, and this is the 2 virtual machines. So you can see this is the UCS virtual machine, this is the second UCS machine, and there's source from the iOS virtual machine running on the Catalyst 9000 platform. You can see the throughput, you can see the latency, and on top of it you can see the diagram which gives information about anything that happens between them. So if we click for example on that link, you can see a real throughput and real traffic in a graph that is measured over the time, and you can see how the application between the 2 virtual machines react. So now let me show you a real deployment on the switch, how this works. So let's first log into the switch. In this case we're using Catalyst 95,000 family. And you can see over here show application hosting. So it looks like the application is currently updating. So let me finish the update, and you can see what is going on after. Let's go to the switch and show you a real application, how the application is hosted on the switch. We have Catalyst 95,000 switch, and here's the list of the applications that are running on that switch. So you can see on that switch we have currently 2 switches, and that is the same CUI that we showed on the GUI, but now the output is really coming from the devices. So I'm going to use this IP address to log into the container itself. So you can see like the log into the container, and that's like a real server that we're using. that case, this container actually supports SSH, so we can log into it or use the web interface to access the container. So that is our virtual machine that is running on the switch. So we can also access the virtual machine through the console of the switch. So you can see this is like the same, and this is the same virtual machine that we're having. Now, this actually gives us the application to install the switch, but that actually is not enough in today's world, because in today's world we're going to have like large number of switches that are deployed in the access layer or any enterprise layer. And we need actually an orchestration tool that is going to give us a way to deploy, install, uninstall, manage, upgrade applications without going to every console and managing every application individually. Currently, the application tool that allows such orchestration is called iOS Fox Director. That application is going to be integrated at certain moment at TNAC Center, and let's go ahead and access this application. So once we log into it, the options that we have is like we have option to first monitor the applications. Let's click on them. So we have option to add a new application. Let's start from there. So we can upload the tab file from the computer, or we eventually in the roadmap is to use a Docker image to create a container of the KVM. Currently we have loaded two types of applications because they are working as a VM, and you can see that the resources that the application actually is going to need. So, if we want to go in deeper details how the application works, we can go to monitor app, and you can see how over the period the application consumes memory, CPU or disk space on the device. We have also option to manage the application per device, because we would like to free resources and install different applications at different moments. So you can see that we have one device that we running the application, one device that we have stopped the application. So how do we do that? Let's go on the device itself, and we have option to stop the device. We have detailed statistics per week, per month, and consumption in chart view. And let's say for iPod, which is a very easy and wide application, we have information that the application stopped. That is a file that we read from the Linux container in this case. So we can quickly stop the application and manage that. So if we go back to the switch, you can see that the switch started to upgrade the application, and after a certain moment we will see that the container is stopped, and that is coming through orchestration tool. So why do we need that orchestration tool? Obviously when we have like 500 switches and 5,000 applications based on the IoT growth, that actually becomes very unmanageable without application like Fox Director, because it literally is going to take months to update the 5,000 applications with so many switches. So now, let's see if the device actually stopped the container. Yeah, you can see like the container actually stopped, and we can go back and power the container up. So let's refresh the application. So we're going back to the same switch, and now we can see that the application actually has stopped. So we have like two options to start it or to remove the application. In our case, we're going just to start the application. Now let's go figure out what are the options under the application. Now we have that device that has like running one-stop application, one application that we have all this information in a visual way, so we can decide what to do, how to host our applications. Going to the iPod, we have option to install or uninstall the application. So now, as long as we kind of have the application on the switch, we can go first and remove the application from the app hosting device. That is going to quickly take out the container. So you can see now the switch is updating the application. Let's wait a little second for that. And later on we're going to add the device application back to the switch. So you can see one application is updating in progress over here. That application is very wide, so the thing should happen really quickly. So now you can see that the iPerf container that we used to have before now is completely disappeared. And if we go back to the device, we can go ahead and install it. So we're going to use our app hosting device. The beautiful piece is that the default director gives the option to validate if the device is capable to host that application, because the device needs to have certain resources like CPU, memory and disk to be able to accommodate that application. We do all the checks for us, and once we click next, we're going to have option to parameterize and analyze what are the source profiles that we want to allocate for that application. We can configure the network access to that application. We have option to bridge. We can put a static address for that application. We're going to use the default setting for now. Just for example, we have all the options to parameterize that application. So now the device is starting to install the application again. So let's wait a few more minutes. So you can see the data graph that gives us information of the progress. So it's currently more likely to deploy the application already. So you can see the status changed to deploy. And once the device changed to a running, we have now the running device. So basically, this is all we wanted to show from device infrastructure that provides to host applications. It gives all orchestration to as well, that gives the option to manage and scale the large number of applications or large number of switches.